The broadcast is now starting. All attendees are in listen-only mode.
Good morning. My name is Mary Beth Smith, and on behalf of the PCTEL team, we'd like to welcome you to today's webinar, PCTEL Solutions for Electric Vehicle Charging, Superior Connectivity and Functionality at Every Charging Station. Were you aware that the number of electric vehicles has increased by 87% to 1 million vehicles since early 2021? However, the growth of public charging outlets hasn't quite kept up, with only a 31% increase, equating to 128,000 charging stations. On the bright side, all indicators have EV charging stations growing at a record pace over the next 3 years. At PCTEL and SmartTech, we have positioned ourselves as the leader in antennas for this market. I'd like to introduce Mattias Hellgren, Director of Product Management at PCTEL. Mattias will review the different levels of charging stations with a specific emphasis on our antenna solutions for reliable connectivity to the infrastructure. Mattias, the floor is yours.
Thank you very much for that introduction, MB. I will discuss and talk a little bit about the EV charging market and also describe why it's so important with connectivity for these type of equipment. Of course, the role of the antenna and the PCTEL. Also mention a few case studies where we supply antennas for some EV charging stations. And then we finish off with some Q&As, and hopefully you have a few of those. Okay. So basically, most of the charging will be done at your home. And in those applications, there is level 1 and 2 chargers being used, which is quite slow charging pace due to that you are not able to push that much current into the batteries. But on longer trips, you will need to charge on the road, so to say, where you traditionally stay at gas stations. And these chargers are level 3 and 4, which is they're able to push more power into the battery, and more or less you can charge much faster. And there is a projective that the electric vehicle supply equipment will have a growth rate of around 25% from 2022 to 2030. And there's also recently come out a draft of a new rule from the European Parliament, where there is a plan of having charging stations at every 60 kilometers along main EU roads. And the member states will have to present their plan by 2024 how to achieve it. So if you look on the ecosystem of electric vehicle charging, you can quite easily see here that connectivity is one of the enablers for the complete ecosystem. And one of the key aspects is actually dynamic load balancing, because it prevents destabilization or overloading of the power grid. And it's on these charging stations, when you draw that much current, you can get unbalanced in the system, and you need to control that. And also, of course, very important is the billing data and user identification. But as you can see on this slide, there is so many different stakeholders within and data that's being sent. And this is made through connectivity solutions. And for instance, you also have diagnostics of the charging station and so on. So you can imagine if you're out driving and arrive to a charging station and it's out of order, and you have planned your trips and mileage on that connectivity, or sorry, the charging station, and you're planning to charge your vehicle. And if it's out of order or the connectivity is lost, the power output will be reduced. So a charge that would take 20 minutes will take several hours instead. So basically then there is several levels of charging stations, where the level 1 and 2 are traditionally for home charging. And then you are using level 2 for shopping malls or office areas or things similar use stations. And then you have highway situations where you have level 3, and also now for trucks and so level 4. And for the level 1 and 2, you're talking about the charging time of 8 to 12 hours, level 2, 4 to 6. But when you're up at 3 and 4, you're talking about 50 minutes, even less on these superchargers. And PCTEL, we are offering antennas for all these type of chargers, depending on how they are designed, of course, if they are built by plastic material or metal casing and so on. But as said before, it's some differences in the requirements for these charging stations. So just basically, what's an antenna? So an antenna is actually a type of transformer. So it transforms conductive signals to radiated signals, and vice versa. And they are resonant devices, similar to, you can compare it to a musical instrument like a guitar or something like that. So they need to be tuned to the frequencies that they should work at. And that's very important to have the complete installation in consideration, and because material surrounding the antenna will have an impact of the performance. And also, it's also important to know that low frequency signals will travel longer compared to higher frequency signals. But also a low frequency will also result in an antenna which is physically larger. So you can't really fit and squeeze down an antenna because you will lose performance. So everything is connected to the law of physics. You can compare this by trying to have a low bass coming out from your speakers at home or in your car. You need to have a large speaker in order to generate that sound, and you will not be able to do that if the speaker is very small. So it's the same thing when it comes to antennas. And we have been delivering antennas and antenna solutions for EV charging for more than 6 years now. We haven't received any antenna back from the field from these customers. And right now, with the PCTEL and the SmartTech combined, we can support customers worldwide with a wide range of products and that could be used in these applications. So this is just a selection. What we have there, as you can see here, there's several different antenna platforms, coach, all disc, mini blade, and so on and so on. These ones are the differences between these is not only the visual appearance, but it's also the frequency ranges, but also how they are mounted. Some of them are adhesive mounted, and others are traditional hole mounted antennas where you drill a hole in the cabinet. Some of them can also have several different antenna functions within the enclosure, not only cellular, but also Wi-Fi and GPS and so on. So we just a case study here to describe something that we've been working with a customer that we've been working with for a very long time, GARO. They're based in the Nordics, and they are one of the major players here when it comes to supplying EV charging stations. And we have an antenna, a smart disc. It's very small and robust and rugged antenna, and it's mounted underneath the plastic top lid. You can see the black part on this charging post there, so it's concealed underneath there. And we have also this antenna in different combinations. This specific customer is using the LTE version, but it's also available in different configurations where you have like Wi-Fi or 2x2 Wi-Fi together with LTE. You can even get it with 2x2 Wi-Fi, GNSS and LTE, depending on your application. And moving on here, also describing another project where we have a customer which is building and delivering superchargers, which is level 3 and even level 4. And these are normally placed out on highways or traditional, where you today fuel your car. These ones will be mounted there also. And it's very important with the load balancing and all the connectivities for these type of chargers, since they're putting out so much power. You need to have this balancing and billing and everything running really smooth, and also that you can do preventive maintenance and these things in order to be able to support the customers with the best offering and stability of your products. And here we have an antenna platform which is all disc small. It goes up to covering the 5G frequencies, and the focus for this type of installation is of course very robust and also very high RF performance. And just imagine just going back and change one of these antennas. It takes a lot of time, so it's a cost for the service technician guy or girl, but the station will also be standing still and will not generate any revenue for the service provider and the one that actually put the charging station at that point. And so you can see that the antenna, it's a small cost in the total calculation. And the oldest antenna, it's an antenna platform, so you can get this configured in many different ways. It's also available in different colors, so you have it in black, you can get it in gray or white. You can also have it just cellular or cellular GNSS, cellular Wi-Fi, and so on and so on. Yes, and also we have prepared like a antenna selection guide, like a spreadsheet for you and your customers, where you can like have a quick view of which antenna to choose. So for instance, the smart blade, the mini blade, which you see here in the middle, the mounting of these two is by adhesive tape, and they are designed to be mounted on plastic material, non-conductive material. And for a level 1 or 2 charger, they could be mounted inside, concealed, so you will not see this antenna from the outside, for instance. And then of course we have the well-known MLPV antenna platform, and really high performance, very robust, suitable for installations where you are in public areas where you could have some issues with people tampering with the antenna and so on. And here of course sales team and the PCTEL are happy to support you with any questions and suggestions when it comes to which antenna to pick and also to use in different applications. And then, as you can see here, you have the LP701 and LP702 They're mounted with screws, but they are available in 2 different versions. Could also be center mounted with a traditional drilled hole. And then these ones, as you can see here, they are mainly focusing on the LTE, 5G, narrowband IoT, and Cat-M. But we also have them with other frequency ranges such as Wi-Fi. And if you need, or your customer needs some type of GNSS functionality, there are also combination antennas that can handle those type of cases. Yes, so that was like a high-level introduction, and I thank you that you've been listening to me, and I hope that we have some questions from the audience. So please.
Thank you, Mattias. It does look like we got a question in the queue. First question is, what does the antenna on the EV charging station talk to?
Yeah, so basically it's connected to the antenna is transferring data to a cloud, and where I will go back to this picture here, so that can give you like the overview of the ecosystem. So basically it's sending information from the EV charging station when it comes to billing data, user identification, which is very important. And also, as I mentioned before, this load balancing, because you can have issues with the grid if you hook up like 20 cars next to each other and everybody would like to charge as much as possible. So you need to balance the power that is actually possible to push through these charging stations.
Thank you, Mattias. Looks like we have another question. What type of data is collected? This is 2-part. And what problem is PCTEL solving?
Yeah, so basically, as mentioned here on the data, it's a lot of data, and there are different stakeholders and using this type of the data. And what's very important is that if you lose connectivity, there is revenue lost, and also customers will be very disappointed with you as a service provider or manufacturer of the charging station. But you can also see it like if you own like a shopping mall or a type of grocery store or something like that, it's easily, and you have the charging stations outside, you can actually get badwill related to the grocery store, not the actual charging station. So it could be like, hey, I'm shopping at this mall, never works, I go to another mall. So using an antenna from PCTEL ensures that you have something that works.
Another question in the queue. Do the antennas provide Wi-Fi to guests waiting during charging time?
Yeah, so basically it's up to the service provider and the one that actually designs the charging stations, but for sure it's possible because there is a gateway or a modem inside of these charging stations, and we have antennas that could support multiple ports, which means you can have Wi-Fi and LTE on the same antenna, in the same antenna. And there are also possibilities to use Wi-Fi as a type of mesh system to collect data and then use one of the charging stations as master to send it up to the cloud through LTE. So I would say we will probably see these type of applications also.
Thank you, Mattias. Another question. Would these types also apply to electric bus charging? We've seen an increase in activity for upgrading bus charging stations.
Yes, for sure. And there we also have like the importance of this load balancing, because when you should charge a bus, we are talking about several megawatts, which means huge power consumption, and it's really critical to balance this, and these chargers are like water cooled even. So in order to do this, it's a lot of power, and that connectivity is really key, because otherwise you will not get anything out of these systems. And we see more and more, and I know there are some more and more trucks coming out with this, having this, and also buses.
Thank you. Another question in the queue. What differentiates PCTEL antennas from the competitors?
I would say there are basically, I would say there's 2 to 3 different things. So one thing is that we test our antennas for environmental and climate influences, such as temperature shift, salt, moisture, rain, and all those things. And we have a very long history of designing antennas to different type of applications, such as the automotive industry, the agriculture industry, and similar applications. So we really know how to design the antennas to withstand over a long period of time. So one thing is to have they can look very similar from outside, but you don't want to get water inside, or you don't want the antenna to break down due to water ingress, for instance. So I would say that the long history of designing antennas, really we have the processes for doing this, both in development but also in production, and the quality systems. And we're also audited by some really large customers within the area, the field of utilities and smart metering, but also from the automotive industry. So both development and production. And that's an added level of assurance that you don't want to go out and replace an antenna, because you lose money on that. And then, of course, the RF properties when it comes to connectivity and those things. And then also right now, as you see, we have a global presence also, with the sales and technical guys both in Europe, and we have in Asia, we have also in US, of course.
Thank you, Mattias. Still have some really good questions coming in. Next question. What are the usual wireless technologies supported by these chargers?
It's mostly the LTE. That's the basically, it's LTE that's being used. In some application is also Wi-Fi, but those 2 are the main ones actually.
Okay. Next question. Are home chargers usually using Wi-Fi connectivity?
Yes, that's very common actually. So you connect to your own grid at home, and these ones are a bit simpler, so to say, and they are most of the time made of plastic, so you can conceal the antenna inside of the housing.
Okay. Next question. Any need for the GNSS use in the chargers?
There could be that it is more like you can use it in a way of like you have like a type of fleet management system, and it could be easier perhaps to pinpoint if you have a problem with a charging station. You can actually get a GPS tag on that exact location, sort of, and send that to a service technician and so on. Normally you will say, yeah, the station is here. So I would say it's not that common, but there could be cases also.
Okay. Another question, can the antennas be painted?
Yeah, it's they can withstand paint, most of them, but it's nothing really we recommend. But it's better to have them colored from us from the beginning. It's tricky to know exactly what type of chemicals and so on, and but basically they will handle that in general.
Another question, do stakeholders such as municipalities, drivers, utilities receive this data for their own use?
No, not really. It depends on the app that you're using and so on. They can of course get some of the data, but they will not get any data related to the load balancing and things like that. But of course, how much they've charged from which provider, and probably also, of course, pricing and so on. But not all data.
Okay. Another question, are the antennas waterproof and vandal proof?
Yes, they are for sure. Some of the antennas that I've shown here before, I can just go down here. They are actually like more of a product family, which is a general market product and multi-purpose. So you can find the coach, the all disc, and the MLPV and so on, for instance, agriculture vehicle, forest machines, buses, and so on. So they have really good IP protection. So ranging from IP67, which is 1 meter of water pillar for 30 minutes, or even up to IP69, which is then they are exposed to 100 bars of high pressure water jet with 80 degrees Celsius water with a testing distance of around 15 centimeters from all angles.
Thank you, Mattias. And see one last question coming in. Where are the antennas typically mounted and how many are needed?
So it depends. If you go looking on the larger stations, like the DC-DC supercharger, there, as you can see on this picture, you see the blue dot. It's most of the time is mounted in the top section, because you will get the best radiation properties at this location. You would like to be high and with an open area, so you can send and receive signals from many different directions. There are also, depending on the routers being used, possibilities to use several antenna elements. They could be combined in one, or you mount 2 antennas with in each corner, and by that you will get diversity and MIMO capabilities. But it relates to the actual modem and router being used from the EV charger.
Thank you, Mattias. And just checking the queue for any last questions. Looks like we have no more questions in the queue.
Okay, perfect. So I would like to thank you all for attending this webinar, and feel free to send me some email and contact me. You have my contact information here, and we will also send you a link if you would like to review this webinar later on. So thank you very much for participating and listening to this webinar from PCTEL.